chapter number 15, the miscellaneous features. What we have done is we have taken the main concepts in C programming, but there are various useful programming features, and that will be very helpful as far as programming strategies are concerned. So we would try in this chapter to examine the enum, that is enumerated data types, the typedef keyword, the typecasting, bit fields, function pointers, function with variable number of arguments, and also the unions. Enumerated data type. So this enumerated data type, it gives us an opportunity to invent or make our own data type, and also to define what values the variable of this data type can take. And this is specially to make our program more readable, as when we write a large program, it becomes complicated, and one or more programmer would be working on it. The programming errors are also reduced using the enumerated data type. For example, say you have created a data type which is called mar_status, and this data type can have 4 possible values, say single, married, divorced, and widowed. And these relationship means the data type you have made along with a type, say some integer. I'll just tell you how you can create this, and you can relate this with the values, and you have created a new data type. I'll just show you. The format of enum, we use enum for enumerated, is similar to the structure. If you have known structure, enum will be very easy for you. So this is a sort of example how we can implement it. This is enum, this is the marital status, okay, and this is the data type I'm talking about, and this is the name of this enum. These are the 4 possible values here, and from here we have created 2 variables of enum. So these are 2 variables of enum, right? Now this has automatically taken the value from 0. Single has been assigned value 0. This is 1, this is 2, this is 3. Now enum makes it easier for us to work with the strings, because we understand the string, but the system understands the number. That is why we have a kind of cooperation between these numbers and these names. Just like a structures, this declaration also has 2 parts. The first part, this is declaring the data type, and it specifies its possible values. So this is the data type. These are the possible values. These values 1, 2, 3, 4 here, they are called as enumerators. The second part is to declare variable of this type, that is person1, person2. Now we can give values to these variables, like person1 was the variable. Now you can assign married to person1, divorced to person2. Please understand, we can't use values that are not used or that are not being described in the original declaration. That is, if you just want to assign person1 with some unknown, this is not going to work. It has to be there in the initial declaration. Now, how this compiler knows and how it treats the enumerators? It essentially treats the enumerators as integers only. So each value on the list of permissible value, it will correspond to an integer which starts from 0, as I just suggested. So the single will be 0, single will be stored as 0 in the system, married as 1, divorced as 2, and widowed as 3. This is how the assignment takes place, but this way of assigning numbers can just be overridden by us. We can initialize the enumerators to different integer values like this. This is enum mar status. Now you can give 100 value, 1000 value, 200 value, 1000 value, any integer value you can give, and you can give, if you give 100, this will be 101, 102, 103, like this. If you want to give specific value to specific variables, it is also acceptable. Now these are the variables here. So what are the uses of enumerated data type? First of all, as I suggested, it is clarifying the operation of the program. I'm just giving you an example. If we need to use employee departments in our payroll program, so it will make the listing easier to read. If we use the value like the assembly, the manufacturing, accounts, if you use number, it will be very difficult. Numbers, we are not very good with numbers, we are very good with the names. So we'll try to make a program that is illustrating what I suggested. This is the program stdio.h string.h. We have an enumeration enum. This is the name of the enumeration, and this is also a data type which is having 4 values. These are 4 values, and in this structure what I'm trying to do here is we have given 3 values, 3 contents basically, and this enum is inside this structure. So we have this enum called department, and now we are making the variable of this structure, struct employee. Now these values, name, age, BS, so we are copying e name to Lothar Matthias to e name, age and basic salary, and also the department. Now department is manufacturing, that is why we have assigned the e.department, and essentially we are giving the value as 1 because it starts from 0. This is 1, this is 2, this is 3. So when we want to print it, you can just print it with e.name because it is a structure, and we know the structure is the values are accessed by the dot operator, e.age, e.bs and e.department. Now, if this e.department is equal to accounts, this is just a check. Just I'm adding some stuff to this program. Essentially, from this point to this point, this is the main program. We're just trying to check that if e.department, if it is accounts, we can just say that this is the accountant, and otherwise, if it is not equal, we can say it is not an accountant. So this is a sample run of this program. Now, this program, first we define the EMP department with 4 possible values: assembly, manufacturing, accounts and stores. Then we defined a variable, as you saw in the program department, of type EMP department in a structure. The structure employee has 3 other elements apart from the employee information. Now, the program first assigned the value to the variables in the structure. The statement of this kind, this is assigning the value of manufacturing to e.department variable. So this is much more informative to anyone reading the program rather than just saying that e.department is 1. What is 1? We are not able to understand 1, but we are able to understand what is manufacturing. So this is how enum works for us. Then the next part of the program is just showing, actually I should say, important weakness of enum variable, because there is no way to use this enumerated value directly in the input-output functions like the printf and the scanner. This printf function is not very smart in order to perform the translation. So the department, as you see, it was just printed as 1 and not the manufacturing word was not being printed. So we can write a function to print the correct enumerated values using a switch statement. I'll show you this example, but again the clarity will suffer. But even with this limitation, there are various situations where enumeration finds their way. Are enums necessary? Why we are talking about enums? If we are making a program, can we achieve the same program, the functioning of the same program without enum? Yes, of course, using macro. This is an example. First, what we did was we created an enum, and this enum, say some name was there, and inside this enum we gave 4 values. These were the values, and they were not being assigned any value, but they already took the value by themselves, like 0, 1, 2, 3. Now we are doing it similarly, same stuff, using the macro. So we have hash defined assembly 0, manufacturing 1, accounts 2, stores 3. We have created a structure here with name, age and basic salary with the department. Now we have created a variable, structure variable. We have assigned various values. And again, e.department is being assigned the value of manufacturing, the name, and this manufacturing is defined as a macro as 1. So the content or the functioning remains the same. With the same effect, the convenience and readability, this can be achieved using macros also. So why should we prefer enums? Because the answer should be macros have global scope always. Macro cannot be defined inside the main. While the scope of enum can either be global, that is if it is declared outside all function, or it can be local if declared inside a function. Then to rename data types with the type definition, there is a more technique that can help us to clarify or reduce the complexity of the source code of C program. So what is the technique? This is to make the use of type def, this declaration. The purpose is to define the name of the existing variable type. How? Just say you have unsigned long int. Okay, this is a statement. Now this is a long statement. You won't be happy if you want to type it again and again. So why not to type define this all long with just 2 words? So this type def we use, we want which content we want to type define, we write here, and this is to which it should be type defined. So now rather than using these, we can just use this to create variables now. So this type defined, it provides a very short and meaningful way to call a data type, as you saw just here. And traditionally we use the uppercase letter. They are used to just to deal with the renamed data type. This is the trivial way we do it. As we just saw that it will increase the readability, right? There are certain situations, I'll just show you with an example. We can also do it with structure declaration. How? This is a structure variable. This is a structure variable, but for that we have made a structure. We have name, age and basic salary. This structure declaration, we can make it more handy. How? We can rename it using type def. See, this is struct def employee, all this content. Then we have just taken type def struct employee EMP. And now this EMP can be directly used because we have type defined this content with this content. Means struct employee will be known in the program as EMP from here now. So this EMP has two variable E1 and E2. So we have reduced the length and also the complexity of the data types. So type defined, I can say it will clarify the source listing, it will save the time and also energy which we spent in understanding the program if the program is written by somebody else. So this type def can also be written in a different way. You can use type def directly here for struct employee. These are the three contents. This is the EMP variable and this is E1 comma E2. That means we have made a variable out of it. So this type def, this can also be used to rename the pointer data type. So how to rename the pointer data types using this type def? This is your structure, struct employee. You have all this content. Then you have done this type def, struct employee, and you have said that you will take or you want to rename the pointer data type. So this is the pointer data type. Now you can make this PMP a variable here, and this P with arrow, that is when you use a pointer, you access the elements of the structure using an arrow like this. So P arrow age will be equal to 32. Typecasting. Typecasting is what? We want to force the compiler to explicitly convert the value of an expression to a particular data type. Let me give an example. Here we have a simple example where x equal to 6 and y equal to 4. So x by y is what? 6 by 4. And this will give you 3 by 2, that is 1.5. But since 6 and 4 are integer, this 0.5 will be truncated because this a is actually float and x and y are integers. So x and y integer, 3 by 2 will give you 1.5 for 5. But because this is integer, before it can be assigned to a float value, this 0.5 value will be truncated. So you'll get 1.000000 like this. Okay, this is the result. This will be your output. So this is the problem here. Now, how to get this 1.5? We don't want this to be truncated, 0.5 to be truncated. That is why we need to typecast it. Please understand this typecasting. We want to make this x as float before it can be divided by y, and the float value need to be assigned to a. Okay, so here is the output. This is 1.5 now. 1.5y because we have typecasted it, force the compiler to make x as float. Once it has become float, no problem, 1.5 will be there. There will be no truncation after the decimal part. So this program uses the typecasting, and as I just said, we have put up parenthesis around the data type name, and we want this float. This is a data type. We want this x to be made float divided by y. So this expression causes the variable x first to convert from integer to float before even going for a division operation. I'll give you one more example. This is a equal to 6.35. Now if I this is a. Now I want to just convert it in the integer. I want just 6. No, not the decimal part. So I will forcefully truncate this point through 5. This is how it is done. For first case, I'll get 6. For other case, this one, I'll get 6.350000. Okay. And one more thing, this typecasting does not change the variable permanently. It is just for that time. Bit field. Bit fields are what? As the name suggests, bit and fields. If you have a variable, say x, and it takes only value as 1 and 0, right? We need only one bit to store. If we have a variable, say x, and it is taking value from 0 to 3, that is 2 to the power 2, 4. So I need only 2 bits. Here I needed only, 1 bit. Again, if a variable goes from 0 to 7, this is 8. So 2 to the power 3 is 8. So I need only 3 bits. Why would I require 8 bit or 16 bit or 32 bit? Because I need only 1 or 2 bits. So we are actually wasting entire integer for that. Okay. But when we have these kind of situation, there is a possibility where we can pack these values in a single memory location. For that we use the bit fields. Okay, if you want to store several values in a single integer, we'll use the bit fields. How does it work? So I'll give you an example. Suppose you wish to store the data like this. Each employee contains, say, male and female. So here we require only 1 bit. Single, married, divorced and widowed. So we require 4, that is only 2 bits are required. This is 2 square, so 4. This 2. Have one of the 8 different hobbies, so we have 2 to the power 3, so I require only 3 bits. Can choose from any of the 15 different schemes, so just say 2 to the power 4, we have 4 bits here. 1, 2 and 3 and 4. So these many bits are required. This means we need 1 bit to store gender, 2 to store marital status, 3 for hobby and 4 for the scheme. Okay, so we need 10 bits altogether. If you just add them, we just need 10 bits. That means we can pack all this information into a single integer, and this integer is 16-bit long. How to do this using bit fields? This is a structure. This is whatever you are using. Now gender, this colon is very important. This colon is saying that gender is going to take 1 bit marital status is going to 2 bit, hobby is going to take 3 bit, and scheme is going to take 4. This colon in the declaration, it indicates the compiler that we are talking about the bit field. This colon is, that is why very important. And the number which is after this, it will tell how many bits to allot for the field. So we have established the bit field using the colon. Now we can reference it just like any other structure element, as I show you here. These are some certain macros we have given: 01 for male, female, 0, 1, 2, 3, 4 for single, married, divorced, and widowed. Now we have a structure here. Here, this is a bit field, and gender is going to use 1. This is unsigned. Then again, marriage status 2, hobby 3, and scheme 4. So we have made a variable here, and now we can assign male, divorce 5, and 9 to the values, and you can just print it. Now you want to print the size also, so you can give just E inside a size of. You will see the size of how many bytes it is taking. It is taking 2 bytes. The structure is taking 2 bytes, and of course the number like 0 and 2. Now pointers to function. Pointers to function. We have been using various variables. We know that every variable has an address. We have seen how to reference the variables like the character, integer, and float. Okay, they all have their address. We can point them using pointers. Now, functions also has address, right? C function also have address, because everything has address. So if we know the function address, we can just point to it. It will provide another way to invoke it. So we can point to the function, we can invoke the function also. So let us see how we can do it. This is a function which is called as display. In this, we have given a printf, which is the display on %u you want to print. And please understand, we have just given the name of the function, and this %u is going to give you the address. This is as simple as that, and rest is the functioning of display. This will show you this string. This is the output. You just have to note, in order to obtain the address of a function, all that we have to do is to mention the name of the function. This is the name of the function just we have given. Okay, just the way we were just giving the name of the array to get its base address, similar is for the function also. Okay, now let us see how to invoke this function. We want to invoke this function. So this is stdio.h. Now we have a display function. Please see this one. We have a void here. Then we have a pointer function, and then ptr, and followed by a round bracket. Please understand this. I am going to explain it. Then we are assigning the display. We know that this is an address. This is an address, and we are assigning it to function pointer. Same is this value. And this is printf. We are printing the address of func ptr, and this is how to invoke the function. Similar. The only thing which remains for us to understand why we are giving it inside a round bracket. Otherwise, things remain exactly the same, and display function is going to display like this. This is a sample run of this program. As you see, we are able to invoke the function also using this address of a function. So we declared the function display as a function which is returning nothing. In main, we have declared the function this, which is returning nothing. Okay. So what is this declaration? We are declaring something, say the function which is upcoming, display, which is going to return nothing, and this function pointer is enclosed inside a parenthesis. So if we take a look at the assignment of this display in our program, we are assigning the address. This is display is nothing but the address to the function pointer. We know this function pointer is being assigned the value, the address of the display, and this function pointer must be a pointer to the function display. Okay, so that is why we have done this void. This function pointer must be a pointer to the function display. That is why we have given as a pointer. And when this is being done, we have to include it in the parenthesis to make this function pointer. This is a pointer to the function display. Okay, that is why we have done this. I hope you got the idea. This function pointer is a pointer to a function which is returning nothing. That is why we have used the void. And how to invoke the function? We are just required to write the statement, this one. We have known why we placed it inside the parenthesis. This is simply function pointer. So pointer to function, they are, you can see they are somewhat difficult to understand. So why we use them? When we can invoke the functions in a simple manner, what is the possible gain of using this esoteric feature of C? Essentially, there are two possible uses if you want to use it. First of all, if you want to implement the callback mechanism used properly and popularly in Windows programming, or you want to bind the functions dynamically, say at runtime in C++ programming. Functions returning pointer. So the way the function is returning integer, float, double, and any other data type, it can return a pointer also. A function can return pointers. So to make a function return a pointer, it has to be explicitly mentioned in the calling function also. First of all, it has to be explicitly mentioned in the calling function as well as in the function definition. So let us see a program, very short program, we have some declaration like this, and this function has some declaration like this. So this program is indicating how an integer pointer can be returned from a function. How an integer pointer can be returned. This is just an integer, this is an integer value, and we are trying to return the address, and this is the integer pointer. The concept can be put to use while handling strings. Look, we'll see if you want to copy one string from one program and to another, it returns the pointer to the target string. We can also use that. So in this, we have a main, we have a function. Now this function is returning the address, and when it is returning the address or a pointer, it is returning the pointer, we have to take it in a pointer. That is how P is shown here. So this is a copying program, one file to another file copy. So this is the source and this is the target. And when it is returning a character pointer. How? Let us see. This is a characters pointer. Now you have a function which is defined here. You have a source, you have a target. You want to copy the source to the target, and you want to print the str. Here, what is going on is, first we have taken T and S. Now this source, because we know that this target is going to change, we took the address of T to some temporary, or say some R. Now this has been taken. Now till we reach the end of the source from here to here, we have to copy one by one to the target. This is how it is done. The source plus plus and T plus plus is done, and the source value has been assigned to the target. And at the time we reach the target end, we have to assign a /0 here, and then we return the R. And this returning of R is taken by char star, and which is being assigned here. Function with variable number of arguments. We have seen printf without even realizing or finding out that the arguments we pass, there is no restriction. There is no restriction. Means we can pass variable number of arguments. So do we have any pointers to do something with it? There are 3 macros which are available in stdarg.h, va start, va arg, and va list. So this situation will be handled because we are going to make function with variable number of arguments. So this macro, they will provide us with the technique for accessing the arguments of the function when the function takes a fixed number of arguments, followed by, first the fixed number of argument, followed by variable number of arguments. The fixed number, normally we access the way we were accessing by now, whereas the optional arguments, they are accessed using these macros, which is va start, va arg. Out of these two, this first one is used to initialize a pointer to the beginning of the list of optional arguments. So this will point to the beginning of the optional argument, while this va arg is used to advance or proceed the pointer to the next argument. So let us see this or try to make a program out of it. Suppose we would like to write a function called find max, which will be finding the maximum values from the set of values, and this is irrespective of how many values you pass. So how to do it? See, this is our stdarg.h, and now this is find max function. We have one integer followed by a dot dot dot, and this dot 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 is known as ellipsis. In this we have a max. So when we find max, these are the numbers which are being passed, and this int is 5. Here also this int is 3. So this 5 and 3, these are fixed. Others are variable. These are variables. So in all, there are 5 variables here and there are 3 variables here. So when we have find max and the maximum is found, can be printed in both the cases. So how this function is going on? In this find max, we have a total number, int total number, followed by the dot dot dot, that is our ellipsis. So we have max, count, and num. As I said, va list is a pointer pointing to the first element of the optional argument. Va start has ptr, this one, because it needs to have a pointer along with the total number. So this is the list, this is the ptr total number, and this va arg, when we pass ptr with this int, right, this is, we have to specify it is int, we get the maximum. And now the initial one, the first one, we try to say that okay, first one is our maximum, and then this is our maximum, then we try to compare it with the next one. See, 23 and 5 is greater than 23. No. So now the max will become 23 rather than 5. This is exactly what is being done here. We start with 1 till total number, and we are incrementing count. Now this va arg, we are passing the ptr and int, and this is num. This num, if it is greater than max, that is 23 is greater than 5, then we assign 23 as the max, new max, and then we return finally when this loop is completed, we return the max. So this find max function, we have declared the ellipsis dot dot dot. This indicates the number of arguments after the first argument, this would be a variable. So we made two calls to find max. First time to find out 5 values, second time to find out the 3 values. And just note that for each call, the first argument is the count of the argument and that follow the first argument. The rest element, the count is this one. So the value of the first argument passed to find max is now collected in the variable total number, and find max now begins with the declaration of this pointer PTR of this type VA list. This is the statement VA start PTR comma total number. So this statement now is getting up or setting up PTR so that it points to the first variable argument in the list. And we are also considering the first call to the find max. Now PTR in this case will point to 23. So this statement max is equal to VA underscore ARG. This is PTR int. This is going to assign the integer being pointed by PTR to the max. So in this case 23 will be assigned to max because 5 and 23, if we compare, 23 is greater. And PTR would now start pointing to the next argument, which is the next argument in the list, which is 15. And this is how things goes on, right? So how about some other program to fix some more ideas? We have a function called display, and this is capable of printing any number of argument of any type. That is, we have a display function. These are integers followed by characters. These are integer followed by the float. So in this case, we have this display function. We have type and integer number, and we have various variable we have taken. Again, VA list is PTR, VA start, we know that PTR has to be there, num has to be there, this num, and we say /n just for printing. Now we come to 3 cases. In these 3 cases, first of all, just see this for. This for is similar for all these 3. From J21 to num, J21 to num, J++. Then this VARG in 3 cases. First is PTR, no problem. Now here, case 1, we are dealing with integer. So we have integers. Second case, we are dealing with character. Third case, we are dealing with double. And now we're printing and breaking. Again, we are printing the character. This is integer printing, character printing, and this is the float printing. And in order to make this double as float, we have used this typecasting. So what we have done here is, here we pass 2 fixed arguments to the function. The first indicates the data type of the argument to be printed. The second was the number of arguments to be printed. So through the statement VA underscore start PTR num, we are setting up pointers such that it will point to the first argument in the variable list of the argument. In the variable list. So depending upon whether the value of type is 1, 2, 3, we print the arguments int, char and float. So in all calls to this display, the second argument indicates how many values we are trying to print. And this is very contrast to printf. To printf, we never pass an argument indicating how many values are we trying to print. So how does this printf know? How does this printf figure out? Simple. It scans the format string. It counts the format string, number of format specifiers that we have used. And according to that, how many values are to be printed? This is done by printf. Unions. Unions are actually derived data types, the way structures are. And in most of the cases, these structures and unions are exactly same. But union has the relationship with structure like a cousin. Union and structure, they look alike, but they are engaged in totally different enterprise. This how we will see just now. Both structures and unions are used to group number of different variables together. So that is their liking. That is why they are similar. But while a structure enables us to treat a number of different variables stored in different places in memory. So structure for integer, it has a different place. For float, it has a different place in the memory. In the case of union only offers a way for a section of a memory to be treated as a variable of one type on one occasion. So this union has only one memory location, that is the longest location of the described or prescribed content. Means we have float, double or integer, will take the double. So this is the highest and only one place is assigned. And depending upon the usage, only this area is used, while in structures, different elements or different data types are assigned different memory places. So why would we want to have such kind of thing? Let us see first an example, then you will understand better. Suppose we have a function, this is demo of union. Now stdio.h we have included, we have a union, the name of union is A, and these are the variable inside, or one is integer, one is character array. And now just assume that we have assigned ch0 as say 0 and ch1 as 2. And now how to make a variable of union? Just say union A key. Now this key is a union variable. Now when we say key.I and you transfer some value, you assign some value, it is all fine. And you want to print it, key.id you can print. This you can print. And when you want to print the character, key.ch0, key.ch1, as I just suggested, 512 has been assigned to this I. 0 and 2 we have assigned to ch0 and ch1, so they will be printed. So the first we declared a data type of type union A. Then we had a variable key of the type union A. This is exactly similar to structure type. Then the structure variables we made exactly as we made the union elements. Now because they are similar union elements, they are accessed exactly in the same manner in which the structure elements are accessed using a dot operator. But just let me tell you first of all the structure. If we compare the data type structure, the name is A and we have I and this character, and struct A key, we have made a variable key. So this data type would occupy how many bytes? 4 bytes. See, if we say integer take 2 bytes, and if we say these two character will take, or character array will take 2 bytes, so 2 plus 2 is 4 bytes, right? So this is how it is done. This is 1002 and this take 1 byte. This is for integer. So integer in all take 2 bytes if we talk about Turbo C and C++ compiler. But for character it is 1, character it is 1. So in all, how many places are being taken? These are 4 bytes. These are 4 bytes. But when we declare the similar data type, instead of structure we are using the union. So union A, we have similar content here. Now we made a variable called key of the union. So this representation is something like this. Now the things have entirely changed. The memory location, the integer is also taking this place, and this character 1 byte is also taking the same place. So both are using this similar memory location. So union now occupies only 2 bytes rather to, or you can say compared to the structure which was taking 4 bytes. So same memory location is used for key.I, that is integer also, and both the characters also. So this means that the memory location used by key.I, this can be accessed using this key.ch0 and key.ch1, right? So what is the purpose it solves? We can access 2 bytes simultaneously using key.I, or the same 2 bytes individually or together. So sometimes we would want that only 1 byte we need to take. Why to take 2 bytes? Or we want to take the bytes individually. So this is a very frequent requirement when we are dealing with the hardware. We are required to access 2 bytes simultaneously, or sometimes we want individual bytes to be taken out. So, and in this situation, union is the best answer. And also the union data type, if we see a fresh look, that we are assigning the integer as 5, 12, the first character array value, and second as 0 and 2. So this 512 is an integer, so it will take 2 bytes, and the binary equivalent of 512 is this. And what we would expect, the binary number when stored in the memory should look like this. It's so simple. It should be like this. But this doesn't happen, because this is the high byte, this is the low byte. This is what we should understand, and we as a beginner we must say that okay, this will be placed like this. This 8 bits will be placed here, and this 8 bit will be placed here. So this is high byte, this is low byte. This is character 0, 1, character 0, character 1, and this is key I total. But in fact, when you output this key ch0, you'll get 2, and if you output key ch1, you get 0. That means it is reverse. It is exactly the opposite. Why? Why is it so? Because the CPU that follow Little Indian architecture, that is mostly we have Intel CPUs, when a 2 byte number is stored, the low byte is stored before the high byte. That means 512 would be stored in the memory location, not like that, but this is the previous byte, this is the second byte. So low byte will be placed here, high byte will be placed here. And if this is ch0, ch1, so when you take out this number, if you print this, it will be printed as 0, this as 2. Okay? So just assume, and just a word of discussion, we can't assign different values to different union elements at the same time, because they are using the same area location, same memory location. That is, if we assign a value to key.I, it gets automatically assigned to key ch0 or key ch1. Or you can say if you assign a value these, it is bound to get an assign to key.I, right? So we have a program here. See, this is 512. Let me start from the scratch. stdio.h, we have a name. This is a union, and we have integer and character. Now we have made a union variable. Now we are assigning 512 to this. And again, this ch2, we are assigning some value, say 0 will be assigned to 0, and 2 has been assigned to 1. Means first character, second character will take 0 and 2. Now when we print it, there is no problem. This will be 512 because it has been assigned. This will be 0 and this is 2. Now things have changed. We are assigning the first, that is this whole location. The first one is now assigned 50. Okay, and now we want to print it. The first will be key.I. But what happened to this? We have assigned the character 0 to 50 and it was 512. So the 512 in this has been replaced by 50, but the next byte in terms of 512, this will be taken along with 50 and final number will be 562. Now you get 562, and this first one again, because this has been replaced by 0 has been replaced by 50, so you get a first value as 50, second value as 2. And before we go ahead, let us try to reiterate that a union provides a way to look at the same data in different perspective. There can exist a union as shown below. This is union. We have double float int char, and this is the union variable. So in what different ways this can be accessed? Several ways are there. As a complete set of 8 bytes like this, as a 4 byte like this, sometimes at 2 bytes. There are 2 bytes we are taking. Or we can take the individual bytes also. This can be done. Okay. So there exists a union. If there exists a union, the elements are having different size. In this case, the size of the union variable will be equal to the size of the longest element in the union. Longest element. Now, union of structures. As structure can be nested within another structure, a union can also be nested inside a union. So nesting of union is possible. Not only this, there can be a union in a structure or a structure in a union. We'll give an example for that. Example of structure nested in a union. So we have main, we have a structure here, we have a structure A, structure B. In this similar items we have given with different names. Now we have a union. In this union we have taken the structure A variable key and structure B variable as data. Now we have made a variable of this union, which is the string. Now we can assign the value like this. And if you print it, you get the proper values like this: 512, 512. 00, 32, 32, right? And as we just saw, one word I have to just say here, that when we are dealing with this string, first we have to go to the key. So string.key, and then we have to go inside this A to access the I or C. So see, string.key.I, string.data.j. So there are 2 levels of accessing being done. So there are 2 dot operators we need to use. 2 dot operator. Utility of union. Suppose you wish to store the information about employees in an organization. So the items are like this: name, grade, age. The grade is if it is highly skilled, then we have a hobby name or credit card number. If the grade is semi-skilled, then we have a vehicle number and distance from company. So in this situation, this remains common for both these. But if the grade is as highly skilled, only these 2 will be taken. If it is semi-skilled, only these 2 will be taken. These 4 will not be taken every time. But if we make a structure because we have a dissimilar information, we need to keep it in a structure. So this we have an grade, age, hobby, credit card number, vehicle number, and distance. If we made a variable E, then we know that three content or 3 data will always be used. But these 2 are optional. Means if highly skilled or semi-skilled, according to that, this data will be used. So what we are experiencing here, there is nothing wrong with this structure, but there is a disadvantage. For any employee, depending upon the grade, either fields hobby or credit card number or the field vehicle number and distance will be used. So both set of fields will never get used, and there will be a wastage of memory with every structure variable that we are creating, since every structure will have all the 4 fields apart from the name, grade and age, which is common to both of them. So how to avoid that? This can be avoided using the union. So I'll show how this is done. We have a struct, we have info1, info2. Now in this we have made a union info. Inside this we have made a variable of info1 and info2. Now here we made a structure which is called employee. In this we have these 3 which are common. For this union info, we have used this one. Okay, now structure employee. The volatile qualifier. When we define a variable in a function, the compiler will try automatically to optimize the code that uses the variable. That means that the compiler may compile the code in a manner that will run in most efficient way. This is done by every compiler in the most efficient possible way. So the compiler achieves this by using the CPU register to store the variable value rather than storing it on a stack. So it does it on a register rather than on a stack. But if we declare the variable as volatile, so it serves as a warning to the compiler that it should not optimize the code containing the variable. So if you have placed it as a volatile, it will not optimize. So in this case, whenever we use the variable, its value would be loaded to the memory into the register operations, would be performed into the memory, and the register operation would be performed on it, and the result would be written back to the memory location allocated to the variable. So there is no optimization being done. So if we declare a volatile variable, we have to put a volatile up before it. So another place where this volatile becomes important when the variable is not within the control of the program, or we know that the variable is going to be altered outside the program. For example, this one, we know this temperature is going to be say modified through some digital thermometer attached to the computer. So let us summarize what we have seen. The enumerated data type or enum and the type def declaration makes your program clear and easy to understand. The typecasting makes the data type conversion for specific operation. And when the information to be stored can be represented using a few bits of a byte, we can use the bit fields in order to pack more information in the byte. Every C function has its address, and that can be stored in a pointer to a function, because for address we can use pointers, and pointers to function provide one more way to invoke or call the function. We can write a function that receives a variable number of arguments. We have seen that. And union is exactly like structure with minor difference, as it permits access to the same memory location in a multiple ways. So this is all about this chapter, which is called as the miscellaneous features. We have taken various features which make our programming more fruitful, more elegant, more you can say efficient. Thank you so much, and take care of yourself.